Hello, dear student. We are going to select very important topics which are coming in the near exam. Let us see. First of all, we will see the chapter 1 of the NCERT, electric charges and fields. What are the important topics? Let us see. And you have to revise. Number 1 is here. When you are going to study about the electric charge, you must think of the important lines about the nature of the electric charge, which is scalar quantities. You should think of it. Next one, in the these very chapters, everybody knows about the basic properties of electric charge. There are so many charges and their properties. What you have to think about quantization of the charges. What is the concept of the quantization? Q is equal to plus minus n into E. You should revise this. Next, some problem based on this quantization you can also revise. Here, what does Q1 plus Q2 equal to 0 signify in the electrostatics? You should also revise such type of the short questions, and you can also revise the problem based on the quantization of charges as well as the two insulated charge copper sphere. Both are identical and having charge QA and QB. Third sphere is brought which is uncharged in contact with the first and then in contact with the second. How to find the new charges on A and B? You must revise also this type of the question. Now next one is the some problems based on the properties of charges. How many electrons are there in 1 coulomb of negative charge? You must also can solve with the help of quantization. The question number here, a metal sphere has minus 6 microcoulomb, and when 5 into 10 to the power 12 electrons are removed from this sphere, what would be the net charge on it? You can also solve such type of the question. Yes, these two questions is the very important question and of very short type of questions. You come to the next type of the important questions. Let us see. Yes, everybody knows about the Coulomb's law, and everybody must revise K times Q1 Q2 by R square, and the formula which is F is equal to 9 into 10 to the 9 Q1 Q2 by R square. This very formula can be utilized. You should also think of the meaning of the 1 coulomb. 1 coulomb should also be revised. This is also very important terms. And the another things which is related with the dielectric constant. Dielectric constant is also very important terms which is to be asked in the examination. You should also revise. During a study of dielectric constant, the Coulomb force is Newtonian in nature. Coulomb's law agree with the Newton's third law. This should also revise. Sometimes teacher used to ask the question based on Coulomb's law in vector form. Only how to write the Coulomb's law in vector forms, you should try to revise this type of the force acting between the two charged bodies in the vector form. Now when you know the concept of the Coulomb force, you must revise one more questions relating with the Coulomb's force Q1 Q2 by R square. Suppose here the question is given some of the 2-point charges, 7 microcoulombs are given and they are repelling each others by a force of 1 newtons, separated by 30 centimeter apart in free space. How to calculate the value of the each charge? You should also revise. Another important questions which must be revised. Let us see. We are coming to the point. Everybody have already studied about the linear charge density, surface charge density, and volume charge density. You should only revise this formula, how lambda is in dq by dt, and how to calculate the Coulomb force, how to write the SI unit of the lambda coulomb per meters. How to express the force with the help of the linear charge distribution. And in the next term, sigma, which is surface charge density, writing the formula dq by ds and SI unit coulomb per meter square. So this type of the very short question must be revised, and expressing the force q naught upon 4 pi epsilon naught surface integration sigma ds by r square. You should revise this type of the calculation also. Here the last one is the delta here dq by dv, volume charge density, and SI unit coulomb per meter cube. There is some problem may be asked in the examination relating with the surface charge density. If you know the formula of charge per unit area of the sphere 4 pi r square, you can calculate the charge. So what charge would be required to electrify a sphere of radius 25 centimeter if the charge density is given? You should think of what is the density and what unit is given, then you change the unit, otherwise you cannot solve. Now another point of discussion here relating with the electric field intensity. We know that field is force experienced by per unit test charge, so you should write the formula and then you should write the unit Newton per Coulomb, and then there may be some short question relating with the electric field calculation. It may be for the point charge, how to write the formula for point charge. Field is q upon r square with the k 1 upon 4 pi epsilon naught. So very short calculation with the help of force and field, you can write the formula for the electric field due to the point charge. Next one is here is the one examples already asked during the 2009 exam. Two charges plus q and minus q are kept at the point. Coordinate of the point is given in the xy plane, and you have to find the magnitude and direction of the net electric field at the origin. So you should also revise such type of the question by locating the coordinate at the point and deciding the distance and relating the field, and you can calculate the value of the total field. In this very chapter, electric field lines are very important. There are so many properties, but the most important properties are the tangent to any point on the electric field lines, so the direction of the electric field. You should revise the point of discussions of the two properties of electric field lines. There may be some question asked with two field lines never intersect. You give the comment why they do not intersect each other. Similarly, if you have a study about the electric field lines, everybody knows the field lines for positive charge going out and field lines for negative charge entered into. So you should also revise the diagram of the charges, but the teachers are used to ask the question for field lines relating to the pair of the charges. Here you can see for positive and negative charges, for pair of charges, how to draw the field line. So you must revise the two diagram for examination point of view. Now come to the another things of this very chapter. Here is one question. The force of 2.25 Newton acts on the charge of 15 into 10 to the power minus 4 Coulomb. How to calculate the intensity of electric field at that point? So these questions also relating with the basic concept of the electric field. Now you come to the question number 18 here. This is also based on the 2-point charges plus 3 microcoulomb each are separated 100 centimeter apart. At what point on the line joining the charges will be the electric field intensity 0? So you make the sketch of the situation of the question and try to apply the formula for finding the total field. Another question is also important, which is why should electrostatic field be 0 inside the conductor? How to explain? You give a reason for the electric field inside the conductor is always 0. Now another short question is also important here. First of all, we will see here charge q is placed at the center of the line joining the two charges. how to show the system of three charges will be in equilibrium if Q becomes minus Q by 4. This question must also be solved. Take care of. Another kind of important question relating with the charges at rest. The charges, 5 charges Q each are placed at the corner of the irregular pentagon of the side A, and how to solve the total electric field at O. Number 1. What is the field at the O if one charge from another corner is removed? So try to solve and revise such type of the important questions. Another important question we have here, question number 35. This is also very important. This is already given in NCERT books. 4-point charges are given and they are located at the corner of the square ABCD, and each side of the square is given. How to calculate the force on the 1 microcoulomb placed at the center of the square. You should also revise such type of the important basic questions. Now you come to the another question based on numerical problems. After revising the conceptual dielectric constant formulas, you may apply such type of the question. Number 39 here, the 2-point charge having equal charges separated by 1 meter and the force is acting 80 Newton. What will be the force experienced by them if they are held in water, if the dielectric constant of water is given? Very simple question based on dielectric constant, you must revise. Now come to the next one in these very chapters. Yes, so chapter wise we will give you the most important questions expected to revise for the examination point of view. There is another most important chapters in electricity, the electric dipole. Everybody knows the dipole is system of minus charge and plus charge separated by very small distance. But the purpose is here to define the dipole moment of electric dipole and what is the direction and what is the formula. You see, think of these two type of the formula, dipole moment, and how to write the SI unit of the dipole moment, coulomb meter. So you never remove this formula. You should bear in mind how to write the SI unit of the. Another kind of important questions based on dipole is the short questions of 2 or 3 marks. How to calculate the electric field at the axial line of any electric dipole. This is the long questions. You can revise by writing the formula for electric fields and calculating, finding the result using the dipole moment meaning. So here results should also be analyzed here. How to calculate the electric field at any point on the equatorial line. This is another type of the star questions to be calculated during the examination. Short type of question it is, and finding the result. You can also see here what is the relation with the field at axial line and field at equatorial line, which is equal to 2. Already asked in the examination. You will also revise this. Now come to the another new topics which is based on the electric field intensity. We are coming to the important point. Yes, we have got importance when electric dipole is placed in the uniform electric field. What is the effect on the dipoles and how to calculate the torque acting on the electric dipole when it is placed. So how to write the formula for dipole? Here we have the result. Torque is the cross product of the dipole moment and electric field. SI unit of the torque is Newton meter. And sometimes teacher asks to write the dimension formula. And most of the examination there are some certain condition given. The case number 1 for the 0 degree torque is not acting. So it is equilibrium conditions. Other is the max value of the torque. Other is the unstable equilibrium conditions. So these conditions must attach with the dipole. Now come to the another conceptual question based on the work done on moving the dipole in the uniform electric field. Very important star question for this examination point of view. The calculation for the work done is P cos theta 1 minus cos theta 2. You will revise. This is also expressed in terms of the potential energy stored by the electric dipole. And under certain conditions, when the dipole is rotated from 90 degree to any angle theta, we get the dot product of the dipole moment with the electric field. So this is very important theory relating to the dipole. Some problems are also based on dipole. We will see here just in the coming question here. You revise these questions, derive the expression of the field due to the dipole at any points from the center of the dipole in the axial line, and draw the graph relating with the electric field and the distance. Now you come to the another questions here. Calculate the max torque acting. When you are revising for the torque, you read these questions and revise. Try to solve when it is field intensity 10 to the 6 Newton per Coulomb. What work must be done? The question is based on maximum torque and as well as the work done. So other conditions is here, anti-parallel at 180 degree. You must revise this. Yes, in the electrostate, the area vector is also important terms. You just only revise the formula. Delta S is n cap delta S. How to write? Electric flux is the most important demanding question for the examination point of view. The flux is EDS cos theta. Flux can also express in terms of the closed integration of EDS cos theta. How to write the SI unit of the flux, Newton meter square per Coulomb. How to write the dimension. This is your duty to revise. Now, the Gauss theorem is the star questions for the electrostatic. Statement must be followed. This should not be altered and changed. And writing the formula to left hand side for the EDS integration over closed integration. And writing Q upon epsilon naught or 1 upon epsilon naught times the charge enclosed in the Gaussian loop. You must revise this theory and prove the Gauss theorem. Another questions of importance application relating with the Gauss law is the infinite long thin wire or conductor. Find the electric field by using Gauss theorem. This is the long question. You must revise by writing all the steps. We will not go into the result is here E times lambda by 2 pi epsilon naught r. So how to the variation of the electric field with the r, this is to be asked in the examination. Another most important after the linear, the infinite plane sheet of charge. This is the star questions of 3 marks standard. Diagram must be clearly maintained and then calculation to find the result is sigma upon 2 epsilon naught. You have to prove this by writing this. Now another third question is importance based on the Gauss law is the thin spherical shell. When the thin spherical shell, the field is outside and the field at the surface and field inside. You must revise once again the whole theory and draw the variations of the electric field with the arc. So this is very important topic in the electrostate. Most of the important question based on the Gauss law and their application, one question must be asked. And if you have the idea of the electric flux through the cube of the 1 centimeter of an electric dipole, how to calculate the electric flux, you revise by using the formula already asked in All India CBC examination. Similarly, we will select some questions here already asked in the question. The electric field is given along x-axis, net electric flux through the cube. We have to find, try to solve and revise for the examination purpose. And one more question here, question number 41 of NCERT. You will divide the electric flux and then try to solve the questions when the charge is at a distance of d by 2. This is the star questions for the examination. And one more question is here, NCERT questions number 43. At above the 5 centimeters, 10 microcoulomb is at the distance directly above the center of the square of 10 centimeter. Calculate the electric flux through this square. Very most important questions. Similarly, we have selected important questions based on from the electrostate chapters. I think this chapters is over now. Next, in the next video, we will once again give you the very important question relating with the electrostats in the of NCERT books.